Hello students, now we will discuss Kirchhoff's law in electricity. Kirchhoff's law. Now we will discuss second law or loop rule. It states that in any loop of a closed circuit, the sum of the products of the resistances and current flowing through them is equal to the sum of applied EMF in that loop of a closed circuit. Suppose these are 2 points A and B and resistance R1 and cell of EMF E1 is connected between them. Between point C and B, resistance R2 is connected, and between point C and D, resistance R3 is connected, and between points D and E, cell of EMF E2 and resistance R4 is connected, and between points E and A, resistance R5 is connected. So we get a closed loop A, B, C, D, E, A of any closed circuit. Between A and B, current I1 is flowing from point A to B, and between B and C, current I2 is flowing from point C to B, and between point C and D, current I3 is flowing from C to D. Between points D and E, current I4 is flowing from point D to E, and between E and A, current I5 is flowing from point A to E. Therefore, according to second law of Kirchhoff's second law or loop rule, mathematically, between the branch A and B, resistance is R1 and current flowing is from A to B, I1. Therefore, point A is at higher potential. So we get a product of current and resistance I1 R1. In the cell E1, potential is increasing from A to B. Therefore, it is negative, mean minus E1. Between point B and C, current is flowing from C to B. Therefore, the potential is increasing from point B to C. So it is also negative, mean minus I2 R2. Between point C and D, current is flowing from C to D. So C is at higher potential. Therefore, potential is decreasing along CD. So it must be positive plus I3 R3. Now cell E2 is connected between D and E, and potential is decreasing from point D. Therefore, it is also plus E2, and in resistance R4 current is flowing from point D to E, so E is at lower potential, so I4 of R4 is also positive, mean plus I4 R4. In the last branch current is flowing from point A to E, so E is at lower potential than A. Potential is increasing from point E to A, so it must be negative minus I5 R5, so it must be equal to 0. That is, between point A and A potential difference is 0, or I1 R1 minus I2 R2 plus I3 R3 plus I4 R4 minus I5 R5 is equal to E1 minus E2. Taking the two terms EMF E1 and EMF E2 to the right hand side, so we get this equation according to Kirchhoff's second law or loop rule. Now other method to obtain this equation, we have two direction anti-clockwise or clockwise. Out of these, consider one is positive and other must be negative. Suppose anti-clockwise direction is positive and clockwise direction is negative. Now mathematically, in the resistance R1, current is flowing from point A to B, that is in the anti-clockwise direction, and anti-clockwise direction is taken as positive, so we get plus I1 R1. Now in between points B and C, current through R2 is flowing from point C to B, that is, it is clockwise in the loop, and in clockwise direction we have taken minus sign, negative, so we get minus R2 I2 R2. Between point C and B, current I2 is in the clockwise direction, so we get minus I2 R2. Now between C and D, current is flowing from point C to D, it is in anti-clockwise direction, and in anti-clockwise direction we have taken positive sign, so we get plus I3 R3. In between point D and E, current through R4 is flowing again in anti-clockwise direction, and in anti-clockwise direction we have taken positive sign, so we get plus I4 R4. And in the last branch EA, current is flowing from point A to E, that is in the clockwise direction, and in clockwise direction we have taken negative sign, so we get minus I5 R5. This must be equal to total EMF applied in the loop. Now in the cell, current is flowing away from positive terminal, and in the cell E1, due to cell E1, current will flow in anti-clockwise direction, and in anti-clockwise direction we have taken positive sign, so this must be equal to plus E1. And in the second cell E2, current is flowing from away from positive sign, that is in the clockwise direction, and in clockwise direction we have taken negative sign, so it must be minus E2. Therefore I1 R1 minus I2 R2 plus I3 R3 plus I4 R4 minus I5 R5 is equal to E1 minus E2. Therefore, according to Kirchhoff's second law or loop rule, in loop A, B, C, D, E, A, we get I1 R1 minus I2 R2 plus I3 R3 plus I4 R4 plus minus I5 R5 is equal to E1 minus E2. So this is the equation we get according to Kirchhoff's second law or loop rule. In the loop A, B, C, D, E, A. So by this method we can get equation between the currents and resistance and EMF in any closed loop of a closed circuit. So this is the Kirchhoff's second law or loop rule. So thank you very much.